आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़।
Celebrating Azadi Ka Amrit Mahotsav, we bring you all a podcast series on STEM popularization. That is, science, technology, engineering, mathematics, and medicine. Supported and catalyzed by the National Council for Science and Technology Communication, the Government of India. Program is produced by Media for Community Foundation. Creative content and technical support is given by Farzeen Sultan.
एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़, की आवाज़।
हमारा ये ब्रह्मांड बहुत विशाल है और इस विशाल से ब्रह्मांड में बहुत सारी ऐसी चीज़ें हैं जो हमारी इमेजिनेशन के बियॉन्ड हैं, और ऐसी ही एक एंटिटी है ब्लैक होल्स। ब्लैक होल्स ओवरऑल काफ़ी मिस्टीरियस और माइंड ब्लोइंग एंटिटी है। अब बात करें सुपरमैसिव ब्लैक होल की, तो यानी ऐसे ब्लैक होल्स जो हमारे यूनिवर्स के सबसे पावरफुल और हैवी ऑब्जेक्ट्स हैं, उनका एग्जिस्टेंस ही एक बड़े क्वेश्चन का जवाब है। तो ये ब्लैक होल्स कैसे बनते हैं और ये कैसे इतने ग्रो करते हैं कि पूरी गैलेक्सी को अपनी ग्रेविटी में खींच सकें। अगर इनकी ग्रोथ की बात करें तो सुपरमैसिव ब्लैक होल्स अपने आसपास के मैटर को कंज्यूम करते रहते हैं, इसलिए ये धीरे धीरे अपने साइज को एक्सपेंड करते जाते हैं। जब इनके आसपास गैस और डस्ट मैटर आ जाता है तो ये एक एक्रीशन डिस्क बनाते हैं, जहाँ से इंटेंस रेडिएशन और एक्स रेज रिलीज होते हैं, और ये प्रोसेस इतना ज़्यादा एनर्जी रिलीज करता है कि हम गैलेक्सीज के सेंटर में इंटेंस रेडिएशन डिटेक्ट कर सकते हैं। इनकी ग्रोथ भी कभी कभी कोलाइड होती है दूसरे ब्लैक होल्स के साथ, जिसमें दोनों ब्लैक होल्स मर्ज हो जाते हैं और ये एक सुपरमैसिव ब्लैक होल का साइज और पावर और बढ़ा देते हैं। तो सुपरमैसिव ब्लैक होल्स ना सिर्फ अपने सराउंडिंग ऑब्जेक्ट्स को खाते हैं, बल्कि अपनी एक्सट्रीम ग्रेविटी के थ्रू यूनिवर्स के सबसे पावरफुल और डेंजरस ऑब्जेक्ट्स भी बन जाते हैं। उनकी एग्जिस्टेंस ही ये प्रूफ है कि हमारी अंडरस्टैंडिंग ऑफ यूनिवर्स कितनी डीप और कॉम्प्लेक्स है। और इसी बारे में विस्तार से हम चर्चा करने जा रहे हैं एरीज यानी आर्यभट्ट रिसर्च इंस्टीट्यूट ऑफ ऑब्जर्वेशनल साइंसेज में साइंटिस्ट डी के पद पर कार्यरत डॉक्टर सुवेंद्र रक्षित के साथ। सबसे पहले जानेंगे एरीज यानी आर्यभट्ट रिसर्च इंस्टीट्यूट ऑफ ऑब्जर्वेशनल साइंसेज में साइंटिस्ट डी के पद पर कार्यरत डॉक्टर सुवेंद्र रक्षित के बारे में।
I am Dr. Suvendu Rakshit. I work here as Scientist D in ARIES, Nainital. So I completed my PhD in 2015 from France, and then several years of postdoc I have done, and then I joined ARIES in 2020 December. So my bachelor was from IIT Guwahati in master in physics. So I work mostly on active galaxies and
अब जानेंगे कि उनका एरिया ऑफ रिसर्च क्या है।
So I work on supermassive black holes. So how they form, how they grow, and how they evolve over time. So think like this: humans also born, they grow over the time, and they eventually die. So similarly, stars also do the same. So star actually born, and they evolve over the time, and they eventually die. At the end, what we left is with white dwarf or a black hole. Now these black holes that I am talking about are roughly 1 to 10 solar mass of the sun. So they are very small, they're tiny. But the star objects that we are studying is very highly massive. It's like billions times solar mass. So now you have a star which eventually formed a black hole of 1 solar mass, and this black hole, how it becomes a billion solar mass, that is the key topic that I am interested in. And to study these objects, I am using sophisticated telescopes from space and the ground, and I'm doing also development of instrumentations. So black hole is a kind of extremely dense region where you have a large gravitational pull. So gravity is so strong that eventually nothing can escape, including the light. So we can consider like a simple way. So let's say you put a tiny but very heavy weight on a thin paper, right? So you will see that there will be a hole in the paper. And now if you put the torch light also on it, or if you throw anything on it, you will eventually lost everything. So everything will be lost. So this thin paper you can consider like a space-time. So you and the black holes are heavily massive and the density is very high. So there is a disturbance in the space-time. So because of that, your information, everything is lost, a kind of infinite density, let's say. So white dwarf is if the objects, the stars are low mass like our sun, so they will become a kind of, so their core will collapse at the end of their death. The core will collapse and their nuclear fusion is not going on there. So their core at the end will be supported by neutron degeneracy pressure. So neutron actually put the pressure. In normal star, what we have is that nuclear fusion taking place. So there is a nuclear energy that is coming outward, and there's a gravity which is trying to pull everything inward. So these two forces balance each other. But here, what you are seeing that there is no nuclear fusion, so only gravity which is trying to pull everything inward. So everything will be squeezed. Okay, so eventually something has to balance it, and here neutron degeneracy pressure is the one who protect or who balance the inward gravity. So these two balancing is there. So that's why you have a white dwarf. It's a dwarf. Sun will eventually will be end up as a white dwarf. That's actually our thing. So there's so there are some nuclear fusion heavy metals. These are going on higher order nuclear reactions. So they eventually become white dwarf, and then they may be becoming black dwarf at further in time. But obviously that black dwarf cannot be seen, and it's so similarly black holes you cannot see.
अब सर से जानेंगे उनकी पास्ट, फ्यूचर और प्रेजेंट रिसर्चेस के बारे में.
So most of the research areas black holes, and then where there's these missing elements. There you have a stellar mass black hole, you have supermassive black holes. What are the intermediate ones? There's one. Then how the galaxies, how these black holes are affecting their own host galaxy, which are the process, how the black holes are getting fed by. So and then how far we can look at back in time. So I'm trying to look at the back in time when the universe was very young. So for cosmological principles. So there are several aspects in terms of science studies. First time I also did several analysis, several kind of research based on big data, the large amount of data volume, exploring the large sky surveys, and applying sophisticated techniques of machine learning and other things, something like that.
उनकी ये रिसर्च ग्लोबली कॉमन मैन और स्टेम के लिए कैसे यूज़फुल है, आइए जानते हैं.
Yeah. So now it's the era of like a big data and machine learning and artificial intelligence. So this research is mostly affecting the basic science, understanding how the universe governs, the laws of physics. But it also helps us to develop the new tools and analysis tools, like improve the artificial intelligence and machine learning methods that we are using currently now, and also sophisticated imaging techniques. For example, the black holes study, the event horizon black hole discovery that was done. Then there was a huge amount of data, and the processing takes a lot of time. Then there was a high performance computing facilities was introduced, and then also sophisticated imaging methods that we see in the medical things. As well as I am developing instruments, and that actually help directly or indirectly to the society, because these instruments needs various components, and the more you sophisticated instrument you want to make, then you need to do more research, and those sophisticated instruments are actually driven by the this science goal of the project. So that's I would say in general it has a lot of applications, and mostly in space science, but also medical imaging and other things. Yeah. So the students will be highly motivated, I guess, and obviously the research community, the catalogs, I make a large amount of big catalogs, and these catalogs are all available publicly. So anybody can use those catalogs and see, for example, the light curves, the variations of flux over the time, and these things can be done. But students will be highly motivated. For example, I came to do astronomy astronomy because I was motivated in my school. I didn't have any kind of like that time there's no cable connections or nothing. And I didn't have TV, but my uncles had a TV. So there was a national, if I remember, there was a National Geography Night Sky podcast, or there's TV shows. And there's a guy, Alex Filipenko, was talking about like explosions in the universe. Okay, so that actually motivated me that time, and then that time I knew, so this may not be for all, but I knew that time that I want to do astronomy. So I slowly chosen, so the path was set that time, but I just wanted to figure out how to go there. So that's maybe these things can be motivated by other people. I mean,
सर की इस रिसर्च में इंडिया ग्लोबली कहाँ रैंक करती है, आइए ये जानते हैं.
So I would say the ranking will be very high because there is a large community working on AGN, and this is thanks to our several instruments or satellites that we have. For example, AstroSat, our own Indian satellite, and then we have a 3.6 meter Devastal optical telescope here at ARIES. And then we also have for example, GMRT, the radio wavelength. So we have access to various facilities working from optical to radio to gamma ray also, and X-ray also. So all the multi-wavelength facilities is available here, and this also helps us to compete with the globally and also collaborate globally with other countries like US and other things. So I would say that definitely there's a lot of progress and happening in this field.
सर की इस फील्ड में इंडिया के कंटेम्प्रेरी और कम्पिटिटिव कौन कौन सी कंट्री हैं, आइए जानते हैं.
Yeah, I would say mostly some people in US, so there are research institutes in US as well as, for example, China and European states also. So this competition actually helps us to also progress faster, right? So we try to develop sophisticated tools so that we can be one step ahead of others. And also collaborations. Obviously, you need to have large collaborations to succeed. And so we have large collaborations because we need a lot of data from different telescopes and satellites. So we need larger collaboration. So this collaboration actually help us positively to increase, to go.
इंडियन इंडस्ट्री इस रिसर्च से कैसे एसोसिएटेड है, आइए इसके बारे में जानते हैं.
Yeah, so Indian industries are associated with development perspective. So for example, as I said that I am interested in instrument development. So mostly for spectrograph and spectropolarimeters, things like that we need for this extragalactic research. So we are developing such instruments, and for individual components, we are actually looking forward to the companies. So they are supplying the components to build the instrument. Sometimes they are building the instrument itself, but sometimes we build here at ARIES, and we take help from them to get their lenses and these things.
अब जानेंगे इनके आर्टिकल्स, रिसर्च पेपर्स और जर्नल्स के बारे में.
So if I consider last 1 or 2 years, there are several articles which are published and which were widely circularized in media also. For example, in few days back with some collaborators at MIT, we found an interesting objects where a supermassive black hole is eating a star itself, and we can look at this phenomena. And this phenomena was published in Science Advance. This is a highly reputed research journal, and it was widely covered by various media in India as well as at MIT and other institutes. There is another one with my graduate students, for example, just 1 month ago, I guess. So we performed a study of an object which is an intermediate mass. So this is a missing link between stellar and hypermassive black holes that we are talking about. So this object we observed using our own telescope here at DOT, Devastal Optical Telescope. Continuously for 2 nights we monitored the same target, and we found there is an intermediate mass black holes with a mass something like 20,000 solar mass or so. So these we also circulating this through the media, and would be that way I guess people will be interested and will be motivated more.
अंत में क्या संदेश दिया डॉक्टर सुवेंद्र रक्षित ने, आइए ये सुनते हैं.
Yeah, sure. Many thanks to this podcast and STEM team, and I hope that this initiative will be influence. I mean, this initiative will be helpful for many students, and because nowadays students are very much interested to know about the cosmos and the many wonders of this cosmos. And so in terms of public outreach perspective, and as well as to motivate the young students, that should be our main goal. So that way, I think that you are doing a fantastic job, and this podcast will be very helpful. All the best. Thank you.
आज के कार्यक्रम में बस इतना ही. हम उम्मीद करते हैं आपको ये कार्यक्रम बेहद पसंद आया होगा. अब हमें दीजिए अनुमति. नमस्कार.